The basic principle is a reflection of the wave. This is the basic principle, simply reflection of the waves. Echo sounder, electronic device to measure the depth of the water. Either we can read the depth of the water or we can read the UKC. बेसिकली इको साउंडर यूकेसी ही रीड करता है और जो ड्राफ्ट है वो ऐड कर देते हैं. That gives us speed, depth of the water. So this device gives us the under clearance, UKC, under clearance. Now what is done? अभी हमने ट्रांसड्यूसर की बात करी थी डॉपलर लॉग में. The same kind of transducer is also used in echo sounder. There is a transducer which is fitted at the bottom, which is transmitting pulses of the acoustic waves. Now, what is this pulse? Pulse means it is not a continuous transmission. तो continuous नहीं है, but it is in pulse mode. That means dot 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 dot, or maybe different type of dot 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 dot, or different kind of dot 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 dot, like that. So pulses are being transmitted vertically downwards, not in this direction as it was in the Doppler log. Here it is transmitted vertically downwards. This pulse which is transmitted travels at the speed of 1500 meter per second. No, in salt water the speed is 1505 meter per second, but we are taking it to be 1500. So the pulse is traveling here at this speed and it gets reflected back. This is received by receiving transducer. This was transmitting transducer. So the pulse which has gone, how much of distance has it traveled? All the way to the deep seabed, and from seabed to this. So total distance is this plus this. That means distance traveled is speed into time. If the pulse was transmitted at T1 and it is received at T2, the time is T2 minus T1. Is that correct? Correct? What do you say? कोई जवाब नहीं आया.
Yes, sir, correct.
All right. So this is the total distance. That means that includes going and coming. So if we simply divide it by 2, we get the depth. So basically depth is equal to, we will write c for the speed of the wave, c into t divided by 2. So the echo sounder is all about finding out the time taken to travel to the seabed, the pulse, how much time it is taking to travel to seabed, and then coming back. Total time calculate करने के का ही device है. That time multiplied by the speed of the wave divided by 2 gives the depth of the water. If we are seeing depth of water, basically, actually this was UKC. If we talk about depth of water, then we must add the draft. The draft should be added to the UKC. So this becomes is equal to C into T divided by 2 plus the draft. Also, it is possible कि ये ट्रांसड्यूसर जो लगा है थोड़ा भीतर लगा है यहाँ पे या थोड़ा बाहर निकल के लगा हुआ है, so there will be some system constants that may be added to this. So the depth of the water is seen to T by 2 plus draft plus the system constants K. This is simply the basic principle. In effect, the working of echo sounder and radar is exactly the same, excepting that this one is measuring the depth, the radar measures the distance of the target or range of the target. यहाँ से ट्रांसमिट करता है, ये टकरा के वापस आता है. Time is calculated, multiplied by the speed of the wave, which is radio wave here, radar में. Here it is sound wave or acoustic wave. But the principle is same. Here also pulses transmitted, here also pulses transmitted. Here also it travels and hits back and comes back. Here also it travels, hits back and comes back. यहाँ पे अगर एक जहाज है मान लीजिए, तो इसे जहाज से टकरा के एनर्जी रिफ्लेक्ट होती है और उसी को हम डिस्प्ले पे दिखाते हैं. यहाँ पे जब एनर्जी आती है तो हम यहाँ पे भी डिस्प्ले पे दिखाते हैं उसको कि कितना डेप्थ है. So this is the basic principle. Any questions on the basic principle? Anyone?
सर एक बार के बता दीजिए फिर से, जो ड्राफ्ट प्लस के लिखा था.
कांस्टेंट. मान लीजिए हमने जो ट्रांसड्यूसर लगाया है अभी, इज दिस द ड्राफ्ट, और अगर यहाँ पे हमने प्रोपेलर भी थोड़ा सा निकलता है तो ड्राफ्ट इज दिस मच और नॉट, है या नहीं?
ओके सर, कांस्टेंट है.
अगर मान लीजिए हमने ट्रांसड्यूसर जो लगाया वो थोड़ा सा यूं लगाया है तो रीडिंग विल बी फ्रॉम हेयर टू हेयर और नॉट?
यस सर.
तो मतलब हमें ये माइनस करना होगा, दिस इज माइनस के. अगर ट्रांसड्यूसर हमने कुछ यूं लगाया है तो यूकेसी यहाँ पे है, ड्राफ्ट कुछ और होएगा. सो इसके इंस्टॉलेशन वगैरह के चलते थोड़ा सा 2 सेंटीमीटर 5 सेंटीमीटर 10 सेंटीमीटर ऊपर नीचे हो सकता है, विच इज द सिस्टम कांस्टेंट. इट इज ऑल अबाउट इंस्टॉलेशन.
अंडरस्टूड सर.
सो बेसिकली ट्रांसड्यूसर जहां पे फिटेड है उसके हिसाब से थोड़ा सा प्लस माइनस करना पड़ता है. दैट इज द सिस्टम कांस्टेंट. So this is the basic principle. Here are characteristics are important. Characteristics of echo sounder which affects the performance. What are the properties that is affecting the performance of the echo sounder? Now suppose when the echo sounder is working, it is reading the depth. There will be limitation कि minimum कितना लेफ्ट रीड कर सकता है. इसके और कम अगर डेप्थ होगी तो नहीं रीड कर पाएगा. सिस्टम हैज गॉट लिमिटेशन. और देयर कैन बी लिमिटेशन कि यहाँ तक तो रीड कर सकता है, इसके ऊपर रीड नहीं कर सकता. मैक्सिमम कितना कर सकता है. So the echo sounder has got a minimum limitation, a maximum limitation of the depth readable. But this depends कि हम क्या यूज कर रहे हैं जिसके चलते ये कितना होगा, क्या यूज कर रहे हैं जिसके चलते कितना होगा. So these limitations basically are defining what is the performance of the echo sounder. मिनिमम कितना कर सकता है जी, इतना ही कर सकता है, इससे ज्यादा कम नहीं कर सकता. So that's performance limitation, minimum, maximum depth and other things also. So they are characterized by certain properties. Number one is pulse length. Number two is pulse repetition frequency. There is also the choice of frequency that we have that decides what kind of performance it will be having. Then there is also something called beam width. These things are related to the echo sounder itself. Pulse length echo sounder का होता है, pulse repetition frequency echo sounder का होता है, frequency and other things all related to the echo sounder, the device itself. But there can be other factors also, the seabed, external conditions, the water that means the salinity and etc. thing, the propagation of the sound waves. So there are external conditions which affect the performance, and there are device considerations which affect the performance. Now the thing is, what is this pulse length and how and what it affects in the echo sounder? What is this pulse repetition frequency? How it affects the performance? What we are talking about the frequency, how it affects the performance, and so on. So one by one we are taking it up. When I said that the echo sounder transducer is transmitting pulses dot 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 or dot 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 or dot dot dot. So in the three examples, I said dot 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 dot. In the second example, I said dot 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 dot. In the third example, I said dot dot dot. Can you see the difference between this and this and this? This was the time during which I was making the sound dot 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 dot. Here dot 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 dot. Here sound is dot dot dot. Lambi lambi आवाज. So if this was done in 1 second, then how many pulses were transmitted in case number 1? 1, 2, 3, 4. How many pulses transmitted?
4.
4. And can you please count for me how many in the second case?
So 3.
सेकंड केस में 3 दिख रहे हैं आपको? 1 2 3
No,
4
sir.
7.
8
7,
9
7, 7. 8.
7 8 9 10 कुछ भी मान ले. And what about the third case?
3, sir.
3. So PRF, pulse has been repeated in 1 second 3 times. PRF here is 3. This has been repeated. The pulses have been repeated in 1 second 8 times. So PRF is 8. The pulse has been repeated 4 times here. So PRF is 4. But we also see a difference that the duration for which I was making the sound was this much here, only this much here, and this much here. This is the pulse length. Pulse length is the time during which the transmission is taking place. Start of the pulse to the end of pulse, the time between that is pulse length. Is measured in seconds or milliseconds or microseconds, whatever. In our case, milliseconds. In echo sounder case, milliseconds. So it is the time when the pulse starts and the pulse completes. That is pulse length. What is PRF? Number of pulses transmitted in unit time, which is 1 second. So are we clear about what is PRF and pulse length? Yes.
Yes, sir. Yes, sir.
Or
Pulse
what
frequency,
is
number of pulses in a unit time. 1 second.
1 second. Unit time छोड़ दीजिए, 1 second बोल देंगे काफी. So in this case, how these two are affecting the performance of the echo sounder? Echo sounder को हमने देखा that it is transmitting signals vertically downwards. From here it is transmitted like this, goes and comes back. This decides what is the minimum depth that will be recorded. This decides minimum depth. How? कैसे होता है ये? How it is deciding the minimum depth? Again, remember the function, how it is happening. Let us say the transmission is beginning. The pulse starts here, then it goes like this. So the condition will be like this. This is the pulse length. इतने देर के लिए पल्स चलेगा. तो अभी आधी पल्स ट्रांसमिट हो गई, आधी निकल चुकी है, आधी बाकी है. अभी डॉट जो होता है तो डॉट है यहाँ पे, अभी टी आना बाकी है. When this goes further, it is like this. Then it goes like this. The pulse is then traveling like this, hits and comes back. So transmission ये हुई or reception when it is coming back here. Let us say it is coming back from here. The pulse will be like this. This pulse which is returned is basically known as echo. So during transmission time we have pulse, and returned energy after reflection is called echo. So right now it is being received. Reception of the echo is just beginning right now, correct? Correct.
Yes, sir.
So this whole thing will be converted into electrical energy, which will be given for recording. हम देखेंगे कैसे. If the transmission was on when the reception is happening, will it be okay? जब मैं बोल रहा हूँ, बोलते बोलते कोई मुझको कुछ वापस सुना दे बात अपनी, तो मैं ठीक से समझूंगा.
No, sir.
अभी साथ में बोलो. अच्छा देखो, अभी आपने बोला और मैंने भी साथ में बोला. आप बोल रहे थे, मैंने कुछ बोल दिया. आपको समझ में आया मैंने क्या बोला?
No, sir.
आपने जो बोला मुझको भी समझ में नहीं आया. मतलब एक बार में एक चीज हो तो सही है, ट्रांसमिट करना है तो कर दूं, फिर रिसीव कर लो. If both things are happening together, it will be confusion, and that is what we are talking about here. So this is all okay because transmission is finished. It has gone all the way and it is coming back like this. But suppose the depth that we are measuring is somewhat less. The pulse is going to start. It has gone like this, then situation is like this. When it hits the ground, still there is transmission on. When it goes back as echo, the condition is like this. When it further reaches here, the condition is like this. अभी भी एक पैसे का ट्रांसमिशन बाकी है. बोलना चालू है जब तक रिसेप्शन के लिए सिग्नल आ गया. कंफ्यूजन होगी या नहीं?
जी सर होगा.
तो ये सिचुएशन कब होगा? जब बढ़िया से ये ट्रांसमिशन खत्म हो जाए और उस समय मैं रिसीव करूं थोड़ा सा और नीचे कि ये ट्रांसमिशन इज फिनिश्ड, then I am receiving this, then things will work, right?
Yes, sir.
This can happen if this was the pulse length and it is coming here, then it is hitting here, then it is going back like this, then it is coming here when pulse is finishing. The pulse was this much. Now what is the depth that we are reading right now? Right now it is okay to receive क्योंकि एक ट्रांसमिशन खत्म हुई और मैं रिसेप्शन कर रहा हूं. What is the depth at this moment? How we can relate it to the pulse length? Is
It
it
is equal
half
to
of the
the
pulse length?
pulse length. Half of the pulse length. Yes.
Half of the pulse length ना, pulse length तो ये जाना और ये आना है, मतलब divided by 2 कर दिया, that is the depth reading. So
Yes,
the
sir. The
pulse length.
minimum.
Yes, go ahead.
Yes, sir. The minimum depth will be the half of the pulse length that can be
Exactly.
measured.
Exactly. So the pulse length value generally varies from 0.2 to 2 milliseconds. Remember that pulse length is the duration during which the pulse is on, the transmission is happening. Dot तो डॉट के बीच में डी और टी के बीच में अगर 0.2 मिलीसेकंड का टाइम है तो पल्स लेंथ 0.2 milliseconds. Let us consider a case when it is 2 milliseconds. So in 2 milliseconds, what is the distance traveled by the pulse length? Distance we know is equal to C into T. C is 1500 meter per second and the T, the pulse length, is 2 milliseconds. That means 10 to the power minus 3. So total pulse length का distance कितना हो गया? The one which is 2 milliseconds is how much in distance? Is it 3 meters?
Yes, sir. 3 meters.
That means the minimum depth it can read is 1.5 meter going and 1.5 meter coming. That means total PL converted into distance divided by 2 is the minimum depth that can be read. Jana 1.5 meter, Ana 1.5 meter. Total pulse length was like this, which was 3 meters. 1.5 gaya, 1.5 आया वापस. So basically, pulse length in terms of distance divided by 2 is the depth minimum that can be read. So in general, what we have, the minimum is equal to C into PL in seconds divided by 2. Remember what we had? 1500 into PL in seconds, 0.2 milliseconds divided by 2. It was 1.5. So D minimum readable for a pulse length of 2 milliseconds is 1.5 meters. Cannot read less than that. If the pulse length is 1 second, 1 millisecond, the depth readable will be 75 centimeters. That means 0.75 meters. Next one is the pulse repetition frequency, number of pulses transmitted in 1 second. So this is dot, dot, dot. We are waiting here between two pulses. There is certain bit of time between this. When the pulse is being transmitted, dot, dot, dot. So is this the time which is here is allowed for it to go all the way and come back here? This is the time during which it is traveling, going down and coming up. एक पल्स का काम तब होगा जब ये ट्रैवल करना शुरू करे, टकरा के वापस आए. एक पल्स का काम हो गया, अब दूसरा पल्स जाएगा, टकरा के वापस आएगा. So how much distance it can go, how much of distance it can go will depend on this time or not.
Yes, sir.
That means if we have pulse like this 1 and 2, एक सेकंड में अगर दो pulses हैं, so this is the time available.
Yes, sir.
If we have PRF which is like this, this is the time available between the pulses. So this is the only time during which it can travel. So in case 1 and case 2, in case 1 where PRF is 4, in case of 2 where PRF is 2, which do you think is going to read more depth?
So where the PRF is 2.
Bingo. So the PRF decides how much of depth can be read because PRF is giving the time between pulses. PRF less, more time between pulses. PRF more, less time between pulses. Less time to go and come back, so less depth being read. So how much is that? That's basically D maximum is equal to C into time between pulses divided by 2. Why? Because we had this time between the two pulses. So this half time will be used in going, half time will be used in coming back. So total distance ये है divided by 2 will be the T maximum. आधा टाइम जाने में लगेगा, आधा टाइम आने में लगेगा. तो मैक्सिमम डेप्थ हम जो रीड कर सकते हैं वो ये है. This total distance is given by C into time between pulses divided by 2 is the T maximum. Are we good?
Yes, sir.
Anyone else? More votes? एक ही आवाज आती है बार बार. प्रफुल्ल साहब. Mr. Praful.
Surrender, sir.
Yes. Are we okay? In short,
Yes, sir.
the frequency. The lower frequencies travel long distance. Higher frequencies cannot travel long distance. The frequency, low frequency, low frequency for deeper waters, high frequency for shallow waters. Because as it is going, it dies out. High frequency cannot travel deep waters. Low frequency can travel deep waters, long distance. But फर्क क्या होता है? Low frequency में poor accuracy. इसमें फायदा क्या है? Good accuracy. So negative part of the low frequency is that accuracy is less, but good part is that it can travel long distance. High frequency में what is the low side? That it cannot travel long distance. But good part that it has got good accuracy. This can be understood by an orchestra. Example of an orchestra. आपके घर से दूर 500-700 मीटर दूर पे 1 किलोमीटर दूर पे ऑर्केस्ट्रा बज रहा है, आपको आवाज आ रही है। आपको कौन सी आवाज सुनाई पड़ती है अपने घर में बैठ के? उस ऑर्केस्ट्रा की जो 1 किलोमीटर दूर बज रहा है, आपको जो आवाज सुनाई पड़ती है, व्हाट इज दैट? इज दैट बूम 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 साउंड, or is that the sharp voice of the guitar, violin, etc., etc.? Which one do you hear more?
Drum, sir.
Drum. That is low frequency. The guitar and finer, sharper voice is the guitar. उसमें भी बेस होता है, बेस वाला अलग स्ट्रिंग होता है और हाई फ्रीक्वेंसी की अलग होती है, तो हम हाई फ्रीक्वेंसी वाले की बात कर रहे हैं, वायलिन एक्सेट्रा। लेकिन अगर आप ऑर्केस्ट्रा में चले गए तो शार्प आवाज कौन सी सुनाई पड़ती है? जो एकदम, जिसको ट्रेबल बोलते हैं, ये हमारा हो गया बास, जो बूम बूम बजता है, लेकिन इसमें क्लैरिटी नहीं होती। ये शार्प आवाज होती है लेकिन दूर तक नहीं चलता। So we have to have a choice of frequency when we are using or making the echo sounder. We have to transmit some frequency in the form of pulses. हमने देख लिया कि पल्स ट्रांसमिट करना होगा, at a given rate ट्रांसमिट करना होगा। Now what is your choice? You will use this or you will use this? Yes. What frequency are you going to use?
For what, sir?
For reading the depth, अगर आप इको साउंडर बना रहे हैं तो इको साउंडर में डेप्थ रीडिंग के लिए आप लो फ्रीक्वेंसी यूज करेंगे, हाई यूज करेंगे?
Sir, high, good accuracy one, high frequency.
तो आप 100 मीटर जाएंगे, आपको रीडिंग नहीं होगी। 100 मीटर के डेप्थ जब देखना होगा आपको 100-150 मीटर, तो आप नहीं रीड कर पाएंगे। क्यों? क्योंकि जाते आते आते मर जाएगा। तो क्या करें?
So, sir, we will lower the frequency.
Lower. That means you are going to have two frequencies?
Yes, sir.
Very good. So that is a choice. In good kind of echo sounders, we have both the frequencies. Dual frequency echo sounder. When we are reading deeper water, I don't want accuracy, but I want the depth reading. So low frequency for deep waters. But when I'm in shallow waters, do I want accuracy?
Yes, sir.
So I will use high frequency. But if there is moderate kind of echo sounder, not expensive one, then we have to have a choice between the two. इधर का कुछ प्रॉपर्टी मिल जाए, इधर का कुछ प्रॉपर्टी मिल जाए, so there will be a compromise between the two. Not very low, not very high, in between. So that is normally between 35 and 55 kilohertz, or maybe 30 to 55 kilohertz. Then a single frequency. When dual frequency receivers are there, then it is about 30, 35, 40 एक, और ऊपर में जाते हैं तो 150, 200 kilohertz also used. Next one is beam width. When we transmit the sound in a wide beam, the energy from here gets dissipated in large area. So concentration of energy at this point or at this point will be less as compared to when we are transmitting the signal as a narrow beam. Then the signal energy, density of the energy here will be more. So
Yes.
if the beam is wide, like I'm speaking to you right now, my voice is going all over the place. सब तरफ जा रहा है. So you are listening. आप मेरा माइक्रोफोन जो है मेरे कैमरे का वो पिकअप कर रहा है. Certain amount of energy is being received by the microphone. But what if I concentrate my energy towards the microphone? I make it narrow beam. I'm speaking with the same intensity. तेज नहीं कर रहा हूँ आवाज, but वैसे ही बोल रहा हूँ. Now, what is the response? Are you listening it louder or lower or the same?
So thoda loud.
Thoda loud. So that is because I have concentrated the energy in a given direction. That is what is beam width. It is transmitted as a beam. If the beam is wide, the depth to which the signal can travel is less. If we narrow it down, it can go deeper water. But we cannot make it too narrow. So it changes. It changes or remains between 7 to 15 degrees or so. So that is the beam width. So in totality, what we have seen that the pulse length ranges from 0.2 to 2 milliseconds. PRF हमने देख लिया कि when we want to read shorter depth, PRF may be high. When we want to read deeper water, the PRF will be less. So in the case of marine echo sounder, it changes between 12 and 36. 12 for deep waters, 36 for shallow water. Frequency, we have seen that from 30 to 55 kilohertz in general. Beam width, 7 degrees to 15 degrees. These are the some standard values. These figures you'll find in the IMO performance standards also, that for shallow water cannot be less than 36, for deep water cannot be more than 12. ये मरीन इको साउंडर की बात हो रही है. दूसरे और सर्वे वाले जो होते हैं उनका PRF can be anything. It can go up to 600 also. So are we good with the properties? Seabed, water propagation condition, etc. That you can understand already from the discussion of Doppler log, etc. So up to this, is it okay?
Yes, sir. So understood.
So we will take the break. Break हो गया क्या? या अभी बाकी है time? Do we have time?
10 मिनट. Yes, sir. 10 मिनट बाकी है.
10-15 मिनट है. Okay, very good, good. मैं समझ रहा था कि time हो गया. How does the echo sounder work? जो हमने बात किया कि transmission takes place, the pulse is transmitted, it hits the seabed and comes back. So C into T divided by 2 is the depth. तो हमारे calculation कैसे होता है? Where is the calculator for this? Where do we do division by 2? Where do we give the input of C and T? Actually, there is no calculator. It is done in a smart way on screen itself. So to record the depth, we have recorders. This recorder can be either electromechanical or it can be electronic. आप लोग जो जहाज में देखते हैं स्क्रीन वाली वो इलेक्ट्रॉनिक है, बट पुराने जहाजों में थोड़े दिन पहले इलेक्ट्रोमैकेनिकल सिस्टम चलता था। तो हम इलेक्ट्रोमैकेनिकल सिस्टम के बारे में शॉर्ट में जल्दी से बात करेंगे। दोनों का फंक्शन बेसिकली एक ही है, मेथड ऑफ वर्किंग एक ही है, एग्जीक्यूशन में थोड़ा सा फर्क पड़ता है, बट प्रोसेस वही है। तो इलेक्ट्रोमैकेनिकल के बारे में पढ़ते हैं कि क्या होता है इसमें। In an echo sounder recorder, there is a roll or drum. There is another paper roll. Basically, paper roll is here. It is wound over this drum. The drum is rotating by motor. So when it is rotating, it keeps on pulling the paper. Keeps. ये यहाँ पे पेपर है, पेपर को पुल करता रहता है. So it is moving in this direction at x-axis, operated by the motor. There is another two pulleys which is placed in this way, up and down. On that there is a belt. This is also motorized. That means it keeps on rotating. When it is rotating, the belt also keeps on rotating like this. On the belt, there is a small metal tip which is installed on the belt. When the belt is moving, the tip also keeps on moving. It keeps on moving like this. So this metal tape is called stylus, and it is moving in this direction. That means y-axis way. So moving in x and y, we can make a point anywhere on the screen. Is that correct? Longitude, latitude से हम चार्ट में कहीं पे भी पॉइंट बना सकते हैं ना?
Yes, sir.
So there is x-axis, which is the paper moving in the x-axis, the stylus moving y-axis. Now what happens? How it is working? That when the pulse is beginning here, when the pulse is beginning, just beginning, it is so synchronized that the stylus is at a 0 point. Let us say this is 0, this is 50 meters. The scale of the paper is 0 to 50. These two are so synchronized. When the pulse is starting from here, the stylus is at 0 point. Let us say the pulse goes 50 meters, you are reading 50 meters down. The echo is going back here. So the pulse, how much of distance has it traveled? Yes.
Twice the distance of speed of sound.
Nah. Twice the speed of sound is the 1500 meter per second.
No, no, no.
Do you
Sorry,
say-
sorry. What?
My question is, the pulse has traveled how much of distance?
Twice the depth, sir. 100 meters.
50 जाना और 50 आना, यही ना?
Yes,
So,
sir. 100 meters.
For the depth of 50 meters, the pulse has traveled 50 and gone back 50. Total is 100 meters. When this signal is received here, this signal is given to the stylus. The received signal is given to the stylus after amplification. Amplify करके stylus को दे देते हैं. जब ये सिग्नल आता है तो स्टाइलस इस करंट से गर्म होता है, हॉट होता है. It becomes hot. And when it is becoming hot, this heat gets transferred to the paper. This is a special type of paper called thermal paper. called thermal paper, and when it is heated by the stylus, it becomes black. It is like this ATM ka paper, which is also a thermal paper. It is heated and it becomes black. So the stylus is touching here. When it becomes hot, it makes a mark, black mark on the paper, and the recording takes place. Now the signal was going 50 meters and coming 50 meters. This depth recording should be recorded on the paper at what place?
So down.
Down. At this place it should be recorded here, correct?
Yes, sir. Yes, sir.
That means at 50 meters depth it should be recorded,
Yes, sir.
correct? Now if you see the the sound wave has traveled 100 meters. During that time, the stylus has moved how much of distance on the scale?
50 meters.
50 meters. So can you see the relationship between the C, which is 1500 meter per second, and the stylus speed? Can you make a relationship between the two? How is the speed of the stylus maintained?
So half.
Half. Very good. So the stylus is rotating at exactly c/2 speed. If this is 1500 meter per second, this is always rotated at 750 meter per second. So when this travels 100 meters, it travels 50 meters. When it will travel 100 and 200 meters, this will travel 100 meters on the scale. So the total distance was here 100. This was C into T, correct? Correct?
Yes, sir.
And here it is moving 50. That means divided by 2, divided by 2. Is it happening? C into T divided by 2 is equal to depth. जो मार्किंग हुई है 50 मीटर पे, ये फॉर्मूला लग गया या नहीं?
Yes, sir.
So there is no calculator. This smart thing is done by the synchronization of the stylus speed with respect to the speed of the sound in the water. The speed of the sound wave in water is 1500 meter per second. This is rotated at 750 meter per second, half to that of C. So this is how this one is working. This device is known as echograph. This is a recorder. Name is echograph. When we have an electronic display or electronic system, there are no mechanical parts, only the screen. और स्क्रीन के भीतर में यही सारा सिस्टम होता है, वही रिलेशनशिप ऑफ c/2, बट देयर इज अ डॉट व्हिच इज मूविंग लाइक दिस. भीतर भीतर जो पिक्सेल्स होती है स्क्रीन की, उसमें चलता रहता है. जैसे ही सिग्नल मिलती है ये वाली, तो यहाँ पे ये डार्क हो जाता है. तो यहाँ पे स्टाइलस बेल्ट वगैरह नहीं है, बट एक ट्रेसिंग स्पॉट है जो भीतर भीतर चल रही है. किस स्पीड से चल रही है? किस स्पीड से चल रही है?
C/2.
c/2. Whenever it is getting signal, it is going to read here. So इसके और इलेक्ट्रोमैकेनिकल सिस्टम के बीच में कोई फर्क नहीं है. Only it is processed electronically. The stylus is basically a tracing spot जो भीतर भीतर चलता रहता है. जैसे ही सिग्नल मिलती है वहां पे ब्राइट करके ब्राइटनेस होकर छोड़ देता है और आगे निकल जाता है. फिर ये चीज इधर को खिसक जाती है पिक्चर इधर को आ जाता है, दूसरा ट्रेसिंग स्पॉट शुरू हो जाता है। So are we clear about how the ecograph is working?
Yes, sir.
All right. Simple block diagram में अगर देखें तो in the bridge there is recorder जो अभी हमने डिस्कस किया, जिस पे डिस्प्ले हो रही थी, साथ में एक प्रोसेसर होएगा, इलेक्ट्रॉनिक्स। प्रोसेसर से डिसाइड होता है कि व्हाट पल्स लेंथ शुड बी ट्रांसमिटेड, कितना डेप्थ रीड कर रहे हैं, पीआरएफ डिसाइड होगी, और उसके बेसिस पे एक ऑसिलेटर है, ऑसिलेटर which is generating electrical signal of given pulse length, of given PRF, of given frequency. So pulse length, PRF and frequency all being guided by the processor. This creates an electrical signal like this. This electrical signal is given to the transducer. Which is having two parts basically, one for transmission, other for reception. This signal which is given to the transducer converts it into electrical signal, mechanical sound wave. The sound waves are transmitted. It is hitting the seabed. Then reflected energy is received by the receiver, which is again a sound wave. But the transducer converts it back into electrical signal. This one is taken to an amplifier. इस छोटे सिग्नल को बड़ा करते हैं और उस बड़े सिग्नल को हम रिकॉर्डर में दे देते हैं। रिकॉर्डर में स्टाइलस होगा या ट्रेसिंग स्पॉट होगा, इलेक्ट्रॉनिक है तो, and on the screen you will have depth reading. So as simple as that, the block diagram of the echo sounder. So we now know the principle that signals are transmitted from the bottom by a transducer vertically downwards. The pulses hit the seabed, get reflected back as an echo. The echo is received. The time between transmission and reception is calculated. That divided by 2 is the depth that we are measuring. We already have seen C into T divided by 2 कैसे करते हैं ecograph में या electronic device. All right. So are we clear up to this?
Yes, sir.
All right. Can we take a break? We'll meet at 3:45. Last class है, 6th class है हमारी. So we'll talk further about. Or one more thing, if you have something specific to ask in the echo sounder, ये तो मैं regular चल रहा था जैसे चलते हैं, but there are few topics which may need explanation. अगर आपके पास questions हैं from the previous classes, तो ask the particular question, क्योंकि एक क्लास में सारा तो हम थ्योरी नहीं कर पाएंगे, 5 क्लास लगती हैं इसमें, 2 में तो खत्म नहीं कर पाएंगे. So if you have specific questions about echo sounder, please do ask me in the last class. We will take it up one by one, query wise query. ठीक है?
Yes, sir.
Yes, sir. Thank you.
All right. चलो ऋषभ, so please find the question that you want to know. एक दो चीजें हैं उसमें, the type of transducer. From my point of view, what I understand is important is the types of transducers which are used, how they work, and their advantage and disadvantage. Is this clear, everybody?
Yes, sir.
Not the new batch, the old batch only. What
Yes.
is ranging and phasing? Do we understand? Important question. Ranging and phasing. Yes, go ahead. मैं wait कर रहा हूँ. दीपांश. सुशील जी. फटाफट बताइए, देर मत कीजिए. We have less time, only one class. सब सोने चले गए हैं लॉग इन करके. सुशील, आर यू देयर? मानन. ऋषभ, मोहित. Ranging and phasing, is it clear?
सर अप्रैल बैच वालों को रेंजिंग और फेजिंग नहीं पढ़ा है अभी.
नहीं पढ़ा है. Okay, ठीक है. So we'll take up ranging and phasing. This relates to the working of the ecograph only. As we have seen how the ecograph is working, that synchronization that we are going to talk about. So we'll go to the board to explain what is ranging and phasing. Just one second, let me set it up. All right, the board is visible.
Yes sir. Yes sir.
Okay. So is it clear? I mean, थोड़ा सा यहाँ पे light कम है, but is it okay? Looking okay to you, the board?
Yes sir, साफ दिख रहा है.
Okay, ठीक है. So we are talking about ranging and phasing. This relates to the operation or the working style of the ecograph. Ecograph में हमने देखा था कि there is a paper roll and there is a stylus which is moving onto this on a pulley. The stylus is here when the transmission takes place. When the transmission is just beginning, the stylus is at 0 point. Supposing you are in range 1, अलग अलग range scale होती है. So let us say the range is 0 to 50. पहला range is 0 to 50 meters. That means this point, the top of the paper is reading 0. This is reading 50 meters. Let us say this is 10 inches of paper. 10 inches is equal to 50 meters. That means per inch is how much? 5 meters. If you are reading 50 meters of depth, going 50, coming 50, 100 meters चलता है, तो ये 50 meters चलता है स्केल पे, स्टाइलस यहाँ पे आ जाती है. Since this is 0 and 50, so we can say this is 10, 20, 30, 40 and 50. If you are changing to second range scale 0 to 100 meters, that means top of the paper is 0 and this is 100 meters. Now,
Yes, sir.
what was 10 meters, 1 inches, 10 meters. Now 10 meter will be compressed within this area or not? Scale छोटा हो जाएगा या नहीं?
Yes sir, 1 inch is equal to 10 meters.
10 meters. पहले 1 inch is equal to 5 meters था, अब 1 inch is equal to 10 meters. अगर हम इससे और ऊपर चलें तो ये और नजदीक हो जाएगा. 1 inch is equal to 115 meters हो जाएगा. और अगर हम बढ़े तो ये 1 inch is equal to 20 meters हो जाएगा. That means reading will become difficult because graduations are coming, scale is becoming smaller. So the graduations become very close. So this is the normal ranging. First case में it is 0 to 50. when we are saying 0 to 50, that means it will be moving from top to bottom in the time the wave travels 100 meters. In second range, because the wave has to go longer distance and come back longer distance, so the stylus speed will become slow. Now it is 100 meters here. So जब ये 200 मीटर चलेगा, 100 जाना 100 आना, that means stylus speed will become small, I mean less. पहले जो ऐसे चल रहा था, अब वो थोड़ा धीरे हो जाएगा, because it has
Yes.
to remain for longer period. Time is now double. When we are reading 150 meters, the stylus speed also will become slow. So अलग-अलग रेंज में स्टाइलस की स्पीड बदलती रहती है. साथ साथ जो ग्रेजुएशंस हैं वो नजदीक आते जाते हैं, स्केल छोटा होता जाता है और हमें रीडिंग में डिफरेंस में फर्क करना मुश्किल होता है. सो दिस इज रेंजिंग. नॉर्मल रेंजिंग जो होती है, इट इज दिस. The starting point always starts at 0 and the range keeps on increasing as we go higher range. इस हायर रेंज के साथ स्टाइलस की स्पीड भी चेंज होती रहती है, ग्रेजुएशन छोटे हो जाते हैं, डिफिकल्टी इन रीडिंग थोड़ा सा ऊपर नीचे अगर हुआ तो एरर भी एम्पलीफाई होता जाता है. नाउ दिस प्रॉब्लम दैट वी आर ऑब्जर्विंग हियर इज सॉर्टेड आउट बाय फेजिंग. सो रेंजिंग में जो प्रॉब्लम है उसको हम एलिमिनेट करते हैं बाय मींस ऑफ फेजिंग. So what happens in the case of phasing? The paper is same, 10 inches. But when we have the phasing, the stylus speed is moving at constant speed. It does not change. How is the range defined then? It is defined as 0 to 50, 50 to 100, 100 to 150, 150 to 200. As you can see, the difference between all of the ranges, upper and lower limit, is how much? So top to bottom is always reading the same difference. That means the scale is going to be constant or not?
Yes, sir.
So scale is constant now. Since the scale is constant, the stylus speed also remains constant. So in one range, when the marking is at this place, it is 0 meter. Marking at this place is 50 meters. But second range, यहीं पे marking हो जाएंगे at this 50 meters. Here it is 75 meters. Here it is 100 meters. This happens when we do the phasing. लेकिन होता क्या है, ये कैसे होगा? How do we do this? So पहला वाला केस तो ठीक है, जैसे था वैसे का वैसा ही. That means the stylus will be at 0 point when the transmission is taking place. When the stylus is at 0, when the transmission is just beginning. So पहला वाला केस तो नॉर्मल जैसा पहले चलता था वैसे. फेजिंग के लिए हम क्या करते हैं? That we place sensors around the belt. There are sensors placed around the belt, and on the belt itself there is a magnet which is placed. There is a magnet which is also installed on the belt. Sensors may be termed as 1, 2, 3, 4. What is happening? That in range 1, where it is 0 to 50 meters, this one is in action, others are out of circuit. ये काम नहीं कर रहे. Sensor 1 is activated. What happens because of this activation? When the magnet is passing near the sensor 1, this will activate the oscillator and the pulse will be started. But incidentally, during that time, when the pulse is starting, the stylus is at 0 position. So this range is okay. The pulse is starting and the stylus is at 0 point. So it goes 50 meters. This comes 25 meters. It goes 50 meters. Then it is coming here. So marking is happening at this place. ये सेंसर सब भीतर में होता है, सामने में पेपर दिखता है सिर्फ. So reading is happening 50 meters here, 0 meters here. When we select the second range, which is 50 to 100, for example, this one is out and this one is put into the circuit. Now what will happen when the magnet is passing sensor 2? Then the transmission will take place. That means this magnet has to be here when the pulse starts. लेकिन ये जो स्टाइलस था वो भी बेल्ट पे, जो मैग्नेट थी वो भी बेल्ट पे. तो मैग्नेट जब पीछे जाएगा तो स्टाइलस भी यहाँ पे होगा या नहीं? क्योंकि इन दोनों के बीच का डिस्टेंस तो फिक्स था. सो ये अगर पीछे है तो स्टाइलस भी पीछे रह जाएगा या नहीं?
Yes, sir.
Stylus is not at 0 point. It is behind only. And transmission is taking place. Now suppose we are reading 50 meters only. So when the signal or the pulse goes 50 meters, this will move by 25 meters. मैग्नेट यहाँ होगी, स्टाइलस यहाँ पे पहुंचा होएगा. When the reflection is coming back another 50 meters, this stylus will come at 0 point. The signal is received and it is given to the stylus. The marking is taking place here. For what depth? 50 meter. 50 meter marking is happening at this place. Why? Because the transmission was advanced. Stylus was not at 0 point. It was behind only, or rather pulse was advanced or it was behind. By the time it is going and coming back, the stylus comes to 0 point, the 0 marking is there. Supposing now we are reading 100 meters. So the pulse will start when the stylus is here, magnet is here. When the pulse goes 100 meters, the stylus will come 50 meters. When the pulse goes back 100 meters again, 100 ka adha, 50 meters down, the stylus will be at this point. The signal is received and given to the stylus. The marking takes place here. Now it is at 100. 50 here, 100 here. So range 1, we had sensor 1 working when the stylus was at 0 point. Range 2, this is an action, this sensor is an action Magnet passes here when the pulse takes place, but the stylus is behind or it is advanced with respect to the stylus by how much? ये यहां से कितना पीछे है? 50 मीटर, अपर लिमिट ऑफ द प्रीवियस रेंज। ये पल्स कितनी पहले चली है? 50 मीटर पहले चली है। 50 मीटर क्या है? अपर लिमिट ऑफ द प्रीवियस रेंज।
It's upper limit of previous.
Yes. When range 3 is selected, same way, this is in action, this is out of circuit. अब जब मैग्नेट यहां पे होगी तो स्टाइलस कहीं यहां पे होगा, स्टाइलस कितना पीछे होगा यहां से? 0 पॉइंट से कितना पीछे होगा?
100, sir.
Very good. Upper limit of the previous range. If we are reading 100 meters only, जब पल्स जाएगी 100 तो ये 50 यहाँ पे पहुंचेगा, ये ऊपर जाएगी और 100 तो यहाँ पे आएगा। 100 marking is happening at this place. If it was, let us say, 130 meters, so 100 मीटर यहाँ पे, 130 मीटर चला गया यहाँ, तो 130 का आधा 65, ये 65 मीटर चला गया, और 70 मीटर्स गया तो 200 मीटर्स हो गया, 200 मीटर्स में 0 पे आ गया, बचा कितना? 130 going, 70, what is remaining? So if you work it out, it will be making a mark at 130 meters. So this is 130, 70, तो 130 में से 70 निकाल दिया तो 60 बच गया।
60, sir.
तो 60 जितने देर में 60 जाएगा उतने में 30 आ जाएगा, so it will be at 30 meters. That means it will read 100 here, 130 at this place. So this is what is phasing. So in short, when we say in normal ranging, the ranges are taken always from starting from 0. In this case, the stylus is constantly moving at a given speed, which is half of this. The pulse transmits when the stylus is at 0. But as we change the range scale to 0 to 100, 0 to 150 or so, the stylus speed changes because it has to remain longer period for on the page paper. यहाँ से यहाँ 50 था तो इतने देर में, अब ज्यादा हो गया तो धीरे धीरे आएगा, और ज्यादा स्केल हो गया तो और धीरे धीरे आएगा. So the stylus speed is changing all the time in normal ranging, and this causes problem of reading. Resolution खराब होती है, graduations become too close, reading becomes difficult. This is sorted out by phasing, in which the stylus is constantly moving at a constant speed only, but the transmission of the pulse is advanced by an amount. How much? How much it is advanced?
By the upper limit of the previous range.
Previous range. Very good. By the upper limit of the previous range. How it is done? By placing sensors around the belt. On the belt there is a magnet. When the magnet passes near the sensor which is in action, so transmission takes place. And that we have seen how it is working. So we are good. What is ranging and phasing?
Yes.
cross noise and aeration. These are noise sources basically. So what is cross noise? Remember that in the ship, when we are having this transducer, one is used for transmission, other one is used for reception. The transmission of the pulse is taking place, it goes down, hits the seabed, it is coming back, it is received by the receiver. When the transmission is taking place, the stylus is at 0 point, for example. Now what happens when the transmission takes place? The receiver is on, तो हमेशा जैसे ही ट्रांसमिशन होगी तो यहाँ पे रिसीव कर लेगा कि नहीं, ये तो जाके बाद में आएगा. ये हर पल्स के साथ, ये बगल में है तो बार बार रिसीव करेगा कि नहीं, हर पल्स को टिंग टिंग टिंग. रिसीवर अगर ऑन है तो जैसे ही ट्रांसमिशन होती है ये तो रिफ्लेक्ट होके बाद में आएगा, पहले इमीडिएटली ये रिसीव करेगा या नहीं. मैं पिंग पिंग बोलता रहूं, कान खुले रहे मेरे, तो अपना पिंग मुझको सुनाई पड़ेगा कि नहीं.
Yes, sir.
100 मीटर जो दूर आदमी है वो तो बाद में सुनेगा, पहले तो मैं ही सुन लूंगा. So what happens? Stylus is at 0 point. Immediately the transmission takes place and the receiver listens. A very strong signal is given to this. तो यहाँ पे डार्क मार्किंग हो जाएगी या नहीं 0 पॉइंट पे, क्योंकि हर बार जब स्टाइलस यहीं पे है स्टार्टिंग में ही तो रिसेप्शन हो जाती है, तो यहाँ पे 0 लाइन पे डार्क मार्किंग होगी या नहीं.
Yes, sir.
दिस इज व्हाट इज कॉल्ड क्रॉस नॉइज. तो इसको खत्म कैसे करें? समथिंग कॉल्ड स्वेप्ट गेन कंट्रोल. ये स्वेप्ट गेन कंट्रोल शायद आपने रडार में भी सुना होगा. Swept gain control is also a feature which is used in the radar. Everything is same about with this and the radar. Now what happens? This swept gain control will bring down the gain of the receiver when the transmission is taking place. जैसे ही ट्रांसमिशन होती है तो रिसीवर का कान जो है वो बंद हो जाता है. पिंग पिंग पिंग. Every time the transmission is there, the receiver closes the ears. So जब बोला पिंग तो सुनाई नहीं पड़ता. अब जब चली गई उधर से टकरा के आएगी, उस समय कान खुला है, ready to listen to the echo. So with every pulse, the gain of the receiver is brought down. जैसे ट्रांसमिशन होती है तो गेन नीचे, ट्रांसमिशन हो गया वो चला गया, अब गेन वापस. So this is happening automatically with the help of a circuit, electronic circuit called swept gain control, which brings down the gain of the receiver. Gain मतलब क्या? The amplification जो receiver हमारा करेगा. So this is what is happening in case of the cross noise of the water. This bubbles will stop the transmission that is passing through this. This becomes a reflecting layer और इसी में से यहाँ से भी कुछ सिग्नल वापस आएगा from the air bubbles. Again, this is also very close to the transducer क्योंकि हल के साथ लगा हुआ है. This also causes dark line near the zero line. Because of the layer of water, a layer of bubbles, some bit of energy is getting reflected back and it is received by the transducer. And so at zero line there is a mark. This can be adjusted little bit with the swept gain control, क्योंकि we can otherwise minimum depth जो reading हो रही है वो भी affected होएगी. So this is known as aeration. Because of air bubbles, the signals getting obstructed, getting reflecting the echo from water layer itself, and so it will result in a dark line near the zero line. Part of the energy will be transmitted and then received, so depth also will be read. But when the ship is going backwards, the propeller here is churning the water and throwing it back. ऐसा होता है कि इसके सामने इतना layer of water हो जाता है, layer of bubbles हो जाता है कि nothing passes through this. Everything is blocked here itself. There is solid line at the zero point area. Nothing goes to this side. In that case, the echo sounder stops working. Only at the zero line there will be a dark line, because the signal is not able to penetrate this. So depth reading will be stopped. Ship going astern, echo sounder does not work so very often. This is known as aeration. To minimize aeration, what we do? We place the transducer at a place where there is least amount of air bubbles expected. इसीलिए कुछ यहाँ पे something like 1/4 to 1/8 length from the bow is where it is placed, where the air bubbles will be dissipating in this area और यहाँ पे आके थोड़ा हल्का होगा. So this is what is cross noise and aeration. Yes, any questions?
सर ऑफ ट्रांसड्यूसर में भी तो लगा, तो वहाँ क्या कहाँ प्लेस करेंगे उसे फिर? क्या कंसीडरेशन रहेगा एरेशन पे?
Very good. So there are two transducers placed sometimes when the ship is very long. एक forward में, एक aft में. Consideration remains same, that it should be away from the sources of bubbles. This also should be away from sources of bubbles. पहला consideration, sources of bubble, away from it. दूसरा ये कि जहां पे वाइब्रेशंस वगैरह कम हो, तो इंजन रूम के आसपास में वाइब्रेशन ज्यादा होगी. एकदम बाव पे जाएंगे तो यहाँ पे भी वाइब्रेशंस होते रहेंगे, क्योंकि यहाँ पे धक्का लगता है पानी का. So when we are placing these transducers, the two considerations is away from vibrations and away from air bubbles. इसमें और कुछ कंसिडरेशन नहीं है, बस यही दो कंसिडरेशन है. ऐसे जगह पे लगाएं जहां पे ये मिनिमम हो. अगर हमने स्टर्न दिया तो ये डेफिनेटली काम नहीं करेगा, क्योंकि ये प्रोपेलर के बहुत नजदीक में होएगा. हो सकता है ये वाला काम करे. So as we said, these transducers are placed somewhere behind 1/8, 4 to 1/8 length of the LOA from the bow. This will happen, this will be the case in longer ships only. When we have two transducers, there has to be clear-cut indication as to we are reading forward draft, forward UKC or aft UKC. It should be clearly indicated. There should not be ambiguity. और आजकल तो सब वैसे इलेक्ट्रॉनिक है तो सब स्प्लिट स्क्रीन होएगा, इसमें फॉरवर्ड डेप्थ बता रहा होगा, इसमें आफ्ट डेप्थ बता रहा होगा. An eco sounder should work well within the range of 2 meters to 200 meters. Minimum UKC that it should read is 2 meters, maximum is 200 meters. If beyond which it is not working, then it is okay as per IMO. But of course, manufacturers will make good devices so that it can read less also, and can read more also. But IMO's requirement is this. The depth reading should be available for any speed that she is built for. If the ship is doing 18 knots, 20 knots, तो full speed पे ये depth reading होनी चाहिए, IMO says. It should read minimum depth of 2 meters, maximum depth of 200 meters, IMO requires. Then there are other requirements also, that for lower depth reading, the PRF should not be more than 36. For deep water, it should not be less than 12. So, like that, there are various kind of IMO requirements. Let us take a look at the IMO requirements of eco sounder. Any questions that you want to still discuss?
No, sir.
Okay. Yes,
Does
बोलिए कोई
muddy water will hamper echo sounder detection?
come again.
If there is a muddy water, and so that does it hamper echo sounders working, in detection?
Yes, it will become difficult because as we were talking about in the morning, that the performance of the eco sounder depends some on the equipment and some on the external conditions. There we clearly wrote the seabed. If the seabed is muddy, the surface is soft and the reflection does not take place so well. Think of a rubber ball. आप एक दीवार पे फेंकिए, वापस आती है. दीवार being hard, it reflects the ball very nicely. Think that wall has got a foam layer. आप उसके ऊपर फेंकेंगे तो रिफ्लेक्शन बॉल की कैसे होगी? Energy will be absorbed by that. So muddy water में performance of the eco sounder is reduced. It is not able to receive signal, or the signals are itself not able to get reflected back so easy. तो वहां पे poor reading हो सकती है. You may not be getting 0, but there may be poor reading. तो जो अच्छा इको आ रहा था, अच्छा शार्प इको आ रहा था, वो थोड़ा हेजी टाइप का आने लगेगा, थोड़ा लाइट आने लगेगा, क्योंकि सिग्नल की स्ट्रेंथ कम हो गई. You can try increasing the gain, तो उससे थोड़ा सा ऊपर होगा. Clear?
Yes, sir.
Okay. There is a question. What corrections you will apply to the eco sounder reading before you compare it with the charted depth? The chart is saying so much, 63 meters. Your eco sounder is reading 53 meters. You are saying, अरे 10 meter difference, मेरा 53 दिखा रहा है, वहां 63 दिखा रहा है. Would you want to add something, some corrections? Will you apply to the eco sounder reading before you finally say, हाँ, this is okay or not okay? Yes.
So draft and tide.
Yes, sir.
First,
Height of tide.
good. Good point. First is the draft.
Draft.
9 मीटर का ड्राफ्ट था, हमने वही ऐड कर दिया. So static draft. Then the tide, because the charted depth is as per the datum. जब मिनिमम होता है उस समय की रीडिंग होती है. When the tide is there, the water will go up and down, of course. तो कितना मीटर का tide है, that may have to be added. Something else?
सर पोजीशन ऑफ ट्रांसड्यूसर कितना फिट है, मतलब वो प्रोड्यूस रहता है ना कितना
Sir,
91 समथिंग.
System CA, system constant, right?
यस सर, सिस्टम कांस्टेंट.
System constant is की वैल्यू उसमें दे दी जाती है. जब इंस्टॉलेशन होता है, प्रोसेसर बनता है, तो उसके फिटमेंट के हिसाब से उसको दे दी जाती है कि ए की वैल्यू इतनी है. मतलब वो जब पल्स जाएगी आएगी जितना होगा प्लस के उसी में कर देते हैं. तो वो हमें लगाने की जरूरत नहीं. वो इंस्टॉलेशन और डिजाइन के समय, इंस्टॉलेशन के समय ही होता है, लेकिन होता है ऑफ कोर्स. तो वो वैल्यू दे दी जाती है, हमें लगाने की जरूरत नहीं पड़ती अलग से. बट गुड पॉइंट.
sir, trim.
So square.
Come
How
again?
the vessel is trimmed. Which transducer we are using, forward or aft, and how is the vessel trimmed?
Trim may be considered, but basically trim के साथ ड्राफ्ट होगा, आफ्ट ड्राफ्ट एंड फॉरवर्ड ड्राफ्ट. तो कॉमन सेंस यही
Yes.
कहता है कि अगर हम आफ्ट की रीडिंग ले रहे हैं तो आफ्ट का ड्राफ्ट का करेक्शन देंगे, अगर फॉरवर्ड की कर रहे हैं तो फॉरवर्ड का देंगे, है ना?
Yes, sir.
So square.
कॉमन सेंस की
Square
बात है.
effect.
ड्राफ्ट हमने कह दिया, वी हैव टेकन दैट इनटू अकाउंट. यस करण?
Square.
वेरी गुड. स्क्वाट. शैलो वाटर इफेक्ट में जहाज चल रही है, she sinks little bit and there can be possibility that she is down by head or down by stern. Because of motion, the bodily sinkage of the ship is taking place. So that also goes down. So squat also should be considered, or shallow water effect must be considered. That should be added. Something else? Anything else? The ship is going like this, heaving is happening up and down, up and down, up and down. Swell की height होगी, average swell हमें आता है weather report में. Swell height 1 to 1.25 meter, 1.2 to 3 meters. So उसमें ऊपर नीचे हो रहा होगा, वो भी देखना हो सकता है. Also there is an important point. जैसा स्क्वाट होता है वैसा ही एक्शन ओपन सी में भी होता है. If the ship is floating just like that without any engines, she will be here. But when she begins the propeller and starts moving, she dips down little bit. She dips down little bit. So it not only happens in shallow water, it happens also in open water. Stationary this much, as she starts moving, थोड़ा सा दब जाएगी. This is called settlement, not squat, but settlement. Actually, जो squat है, that is not necessarily the bodily sinkage. Squat is basically when there is a change, when there is the bow which goes down or the stern that goes down. वो टेढ़ा जो होता है उसको बोलते हैं स्क्वाट. हिंदी में स्क्वाट को क्या बोलते हैं? What is squatting?
गोता लगा.
गोता लगाना नहीं, गोता लगाना नहीं. A wrong example. बट हमारे यहाँ उसको हमारे बिहार में बोलते हैं चुक्को मुक्को बैठना या उकड़ू बैठना। उकड़ू बैठना मतलब मालूम है, ऐसे करके झुक करके। यस,
हाँ सर समझ।
तो हाँ, तो झुकने को बोलते हैं स्क्वाटिंग। दैट इज स्क्वाटिंग। समबडी इज स्क्वाटिंग मीन्स झुका हुआ है। तो बाव जो नीचे जाती है उसको बोलते हैं स्क्वाटिंग, या स्टर्न जो जाती है नीचे उसको बोलते हैं स्क्वाटिंग। बट bodily sinkage as a whole is out in the open sea is something called settlement. That all may have to be considered for correction. एक चीज जो आप लोगों ने नहीं कहा, which was most important, is the correction of the wave propagation. C. हमने देखा कि stylus is moving at half the speed of the sound waves. The sound wave is taken as 1500 meter per second. So the stylus is moving at what speed? 750 meter per second. You are going to fresh water. The sound speed has changed to 1450, but this is again 750. ये तो उसको तो मालूम नहीं. So
Yes, sir.
the sound speed has become 1450 meters, but here you are talking about the stylus moving at the speed of 750 meter per second. Depth सही बताएगा या गलत बताएगा?
गलत बताएगा।
गलत बताएगा. To get the right speed, you have to divide it by 2. Relationship between the two should have been 1/2. अगर वो नहीं है तो गलत आएगा. So just familiarize yourself. Familiarize with the performance standard requirements of the echo sounder. So normally first the introduction will be there. That echo sounder is used for depth measurement. Either it should provide the depth measurement at the full speed of the ship or at least 30 knots. The speed of the sound waves that we take is 1500 meter per second, as already discussed so many times. And point by point, these are some of the requirements जो हम बात कर रहे थे. Point number 1, the UKC measurement should be possible within the range of 2 to 200 meters. It can be beyond this, yes, but not less than this. Minimum 2 range scales required, one for low, other for high. So 0 to 20 and 20 to 200 minimum 2 range होना चाहिए. But example में हम देख रहे थे if there were other ranges also possible. Graphic display.
Yes, sir.
Graphic display should be there, which we have already seen on the paper or on the LCD screen. Also, it is required that in one view, we should be able to see the last 15 minutes depth. That means जो पेपर का साइज है, अभी जहां पे स्टाइलस घूम रही है वो तो अभी करंट का है, लेकिन उसके पहले 15 मिनट का कम से कम जो डेप्थ रीडिंग थी वो भी क्लियर होना चाहिए. PRF we talked about should not be lower than 12 pulses per minute or 36 pulses per minute for shallow range. Remember, PRF is less for deep water, more for shallow water. When the ship is rolling pitching by an angle of 10 degrees and 5 degrees respectively, rolling 10 degrees, pitching 5 degrees, then also the system should work quite reliably. Similarly, there are some points you can just go through it. Point number 8 talks about the possibility of error plus minus 0.5 meter on lower range scale. मतलब आधा मीटर का allowance is there. When we go to higher ranges, then plus minus 5 meter भी हो तो भी चलेगा. So more accuracy is required in the shallow water areas, and for that what we do, more accuracy के लिए short pulses and high frequency.
Yes, sir, high frequency.
Short pulses and high frequency. Alarm should be provided, malfunction alarm should be there, mute button should be there. So these are some requirements of the IMO performance standards for eco sounder. We were talking about the resolution going bad in ranging. So that is the point that is indicated is point number 9. तो उन्होंने define कर रखा है कि minimum जो 1 मीटर का range है, that should be defined by at least 5 mm का distance. Point number 9 you can see. The scale of display should not be smaller than 5 mm per meter depth on the shallow range and 0.5 mm per meter for deep range. मतलब shallow water में 1 मीटर या 10 मीटर और 11 मीटर के बीच का डिफरेंस जो है कम से कम 5 mm का होना चाहिए on the paper, on the graph. So that's about it. I think you have all these documents with you, right?
Yes, I have to check. We have got the handout. I have to check.
हैंडआउट मैंने तो आपको पर्सनली भेजा हुआ है मेरे ख्याल से. मैंने ईमेल में भेजा हुआ है. ये जो है यही ईमेल मैंने आपको भेजी है मेरे ख्याल से.
सर अप्रैल बैच वालों को नहीं मिला सर.
क्या बात करते हो, नहीं मिला है?
नहीं सर,
नहीं मिला.
नहीं सर, अप्रैल बैच को कुछ भी नहीं मिला सर.
ओ अरे ओ, तो मैंने सेकंड मिनट को भेजा, आप लोग को नहीं भेजा? ऐसा कैसे? ओके, दिस इवनिंग
नहीं भेजा.
तो क्या रात में कभी भेज दूंगा. ऑल राइट, ठीक है. आप लोगों ने बोला भी नहीं नोट्स नहीं मिला. चलो ठीक है, नो इश्यूज.
सर हमें
सो एनी मोर क्वेश्चंस? एनीवन?
नो सर.
Okay, so this we did for the benefit of the February batch who is going for the exams from tomorrow. I think tomorrow or day after. कल ही से ना एग्जाम आप लोग का? कल 7 तारीख होगी, 5 तारीख? अच्छा, जब भी है. So we will continue with the Doppler log tomorrow. We'll complete the topic. जहां तक हमने पढ़ा था that was good. कल के 2 क्लास में, एक क्लास में हो जाएगा मेरे ख्याल से, ज्यादा कुछ बचा हुआ नहीं है. So we'll talk about Doppler log. अगर कुछ टाइम बचा तो more focus on the echo sounder so that we are done with the echo sounder also for the new batch. ठीक है. So with this we conclude the class. I think we haven't got anything to discuss now. Juvi. Yes. कोई कुछ नहीं बोलता.
अप्रैल वाले के लिए ठीक है सर,
हाँ जी.
नए बैच वालों के लिए हम लोग का तो हो गया सर.
हाँ, नए बैच वाले के लिए बाकी तो कंप्लीट कर ही दूंगा ना. आप तो कल से एग्जाम में चले जाएंगे. राइट. ओके, देन वी साइन ऑफ.
ओके सर, थैंक यू.
ठीक है, चलिए साइनिंग ऑफ, क्लोजिंग द क्लास नाउ.
Okay, sir. Thank
5
you.
मिनट पहले
Have a
छूट
good
गया.
day, sir.
Thank you. Thank you.
कल हमने 15 मिनट. Range selector switch is an important switch. It is not very unimportant kind of switch. Why? Because wrong selection of the range may result in error in the recording. What you are looking at on the recording, the depth being shown, may be wrong if you are selecting the wrong range. When the depth is 100 meter, you are keeping 50 meter range. When the depth is 50 meter, you are keeping 100 meter range. In both the cases, there can be errors in the recording. So the range selector switch must be selected such that the depth you are reading should be within the selected range. For example, 100 to 150 meter का range है आपका. So you must be reading the depth. The C depth should be between 50 and 100. अगर इससे बाहर होगा तो there can be error. Paper speed knob, इसके बारे में बात किया था. We can change the motor speed of the drum which is pulling the paper. That y-axis movement of the paper can be controlled. In digital recording, this may also be available, but it won't be actually motor control, it will be electronic control, how fast the reading is taking place. If we use low speed, the paper will last for longer period, but the resolution of recording will not be good, that we have seen earlier. If the paper is fast, the resolution of the printing, also the profile of the seabed will be clear more effectively, but the paper will run short very quickly. Paper will finish. Then there is stylus speed control. Stylus speed में आपको पता है कि the stylus is running up and down like this on the paper. The speed of this stylus should be 750 meter per second. This can be adjusted, it can go up, it can go down. So manufacturer's manual should be referred to for controlling the speed of the paper so as to match with exact half the speed of the sound wave, which is 1500 meter per second. So 1500 divided by 2 is equal to 750. That is the speed of the stylus. It should always be maintained at 750. If not, then there can be error. Sensitivity control knob. Remember the block diagram that we had, that there is recorder, from here oscillator, from here transducer. Transducer से जब signal वापस आता है electrical signal, then we had an amplifier. So amplifier में we can increase or decrease the strength of the signal that we are amplifying. So the small signal can be converted either into small signal or medium signal or larger signal. Depending on what kind of signal we are giving to the recorder, the recording darkness will be adjusted. More signal, more darker recording, less amplification or less gain, little lighter recording. So when we are in the deep sea, the signals are coming from long distance, going all the way down and then coming back. Possibly, the signal will be very weak, so gain should be kept high. In shallow depth, because it is coming from a closer distance, so the signal strength will be more. Gain should be reduced accordingly. It should be adjusted so that you are getting right kind of desirable picture, not too light, not too dark, but just in the middle. So that is sensitivity or gain control. You have this draft setting control knob. When you are trying to read the depth of the water, you of course must add your draft to the UKC. So there is this control provided so that you can input your draft setting into the echo sounder. The results will be shown with together. I mean the UKC plus the draft. That recording will be shown on the echo sounder. Generally, by this draft setting, what we do, we advance or retard the transmission of the pulse. जैसा phasing में किया था, वैसे ही हम यहाँ पे भी करते हैं, लेकिन in a controlled manner. नॉब जैसे जैसे घुमाएंगे, वैसे वैसे डिले चेंज होगा. I hope you are understanding. But nonetheless, छोड़ दो कैसे काम करता है, बस इतना जान लीजिए कि इसका फंक्शन क्या है. You have unit selector. You have then fixed marker. Unit selector feet fathom meter हो सकता है, नहीं भी हो सकता है, but may be possible. There is fixed marker. When we are using this fixed marker, it is a spring-loaded push button. So when we push this fixed marker, a constant supply is given to the stylus. Constant voltage is supplied to the stylus, and so the stylus starts making the mark here क्योंकि ये heat हो रहा है, and since it is constantly supplied, by pressing the button, there is a continuous mark from top to bottom. As the stylus is going down, it keeps on marking on the paper. So ऊपर से नीचे लाइन खींचने का मतलब क्या हुआ? हमने पेपर पे ऊपर से नीचे एक वर्टिकल लाइन खींच दी by pressing this fixed marker. This is basically an event marker. Something, some position you are crossing, you want to note down at this time we have crossed here and this place was here. So you are pressing this button और इसके साथ आप जो चाहते हैं notes वो पेपर पे लिख दे सकते हैं. Like sometimes when we are making entry to the rivers, you have to cross the bar. The shallow line where the silt is getting deposited because of the flow from the river, तो जमा होता है. What is that actually? As the river is flowing, there is sea. The river brings in a lot of mud and it will deposit the mud like this, mud or sand or something. So when the ship is coming and crossing this place, sometimes there is a chance of touching this bottom. So in that case, you can press that fixed marker to see that when we passed here at so and so time, the depth was so much. This we had seen when getting into Amazon. Amazon river में घुस रहे थे हम लोग, coming from USA. Then we had to pass this bar, and we had to wait for the tide properly so that we get the maximum tide when we can cross the vessel. So you can mark that event by using the fixed marker. Then transducer selector switch. In the ships, when you have two transducers, one to read the forward draft, other to read the aft draft in long ships, you can select the particular transducer. You have one recorder. Basically, recorder is one, but there can be aft transducer and there can be forward transducer. So recording का जो input जा रहा है, which recording is being shown, that should be clearly indicated on the screen that you are now reading forward draft and forward UKC, and this is the recording. So you have a switch. You can select the aft or you can select the forward transducer. Whatever you select, that recording will be shown on the recorder. The recorder should have clear-cut indication which depth you are reading. So as it changed over the switch, there will be some marking on the paper that now from this point on, you are reading aft draft or aft depth, UKC, or when you change over to forward, it will clearly indicate that this depth that you are reading is forward depth. Panel brilliance control knob. This you know, every device has got that controllable light, which should depend on the ambient light available in the bridge. So for reading, sometimes you can change the illumination of the screen. So these are some of the controls that we have. Any questions on the controls? Please verify your understanding. Any questions? Yes.
Sir, understood.
Okay, all clear. इसमें भी कुछ दिक्कत तो है नहीं, मेरे ख्याल से सब क्लियर होना चाहिए. Maintenance of the echo sounder. When it is in operation, you have to maintain it, especially the electromechanical type. Electronics वाले में तो कुछ ज्यादा नहीं करना होता है, because everything is electronic, सारा signal processing से ही होता है. But in the electromechanical system, where there are motors, there is belt, there is stylus, the recording happening due to heat transfer. In that kind of system, there has to be a regularly maintained device to give you right kind of recording, right kind of depth. So as a navigator, you must keep looking at it and keep it maintained in the prime condition so that your recordings are in the best possible manner you are getting. As we have already understood how it works, from common sense, we can understand that few of the maintenance that has to be done in order to get the right recording. Number one, printhead or stylus cleaning. As we know that the stylus is printing on the paper with the help of heat transfer. When the stylus is heated, the paper, the carbon on the paper, which is thermally coated, the carbon of the paper keeps on getting deposited onto the stylus. जो स्टाइलस है उसके ऊपर में कार्बन डिपॉजिट जमा होने लगता है. So paper is here and the carbon deposited here at the tip of the stylus. So what happens? The heat transfer does not take place properly to the paper. सब कुछ सही काम कर रहा है, but since there is a deposit of the carbon on the print head, the heat transfer is not taking place, the recording does not take place. So what we should do, periodically we should clean this. Clean this print head with the help of either solution provided, or if nothing, simply isopropyl alcohol कॉटन में डिप करके टिप को साफ कर देते हैं. So first one is print head cleaning. Printer or recording paper, printer paper or recording paper, whatever we say, it is continuously being pulled out. So it should be maintained in full condition or sufficient condition so that it is not finishing during the important passage that we are doing. So the roll has to be replaced when it is finishing. How do we maintain, how do we manage that? There will be a watermark, red color mark on all the paper rolls you have seen, correct? In the end, there is a white paint or white mark is there. Pink or red mark is there. Is that correct? All papers, whether it is Navtex paper or SATC ka paper, EcoSounder ka paper, any paper, there is this watermark to indicate now the paper is finishing, you should be ready to change it. So that recording of the recording paper. Then moving parts should be lubricated as per instructions provided. There are motors, so there may be some kind of oil or something that may be required. They try to make it maintenance free, so you may have self lubricating carbon washers and all that. So you have to watch whatever the manufacturers say about this maintenance, you should follow that. Cleaning of transducer is not generally done when we are out at sea, that is underwater. But when we go in the dry dock, we should make it a point to clean the transducer and cover it with paper or something, or the canvas, so that no painting and things are done onto the transducer. If paint is done, then the transmissions will get affected. So it should be cleaned when you have an opportunity in the dry dock. Look for it where it is located, clean it, cover it, so that painting is not done on the transducer. Then, in order to use and get useful information from the transducer, you should do calibration of the thing, calibration of the device. Now, we have already understood in the Doppler law what is calibration. Calibration is a process to determine that the device is giving right kind of readings as expected. Otherwise, you don't have any means of comparison with the EcoSounder, because transmission is taking downwards and everything is happening there itself. You are finally getting the result on the recording paper or the screen. So it should be tested against manual sounding, especially when you are in jetty. You know that there is a depth by manual sounding. Using the sounding tape, you can take the depth of the water and switch on the EcoSounder, compare it with the EcoSounder and see what the EcoSounder is saying. If any difference, it should be noted. You cannot do much about this, but you now have a margin that you should add or subtract to the reading. अगर कुछ error था तो you will have an idea कि हमारा echo sounder 30 सेंटीमीटर 40 सेंटीमीटर कम दिखाता है, तो जो भी रीडिंग है उसमें 40 सेंटीमीटर ऐड कर देंगे, ज्यादा दिखाता है तो माइनस कर देंगे. So that should be done. So those are few of the maintenances to be carried out. As we already said, electronic devices में, electronic displays में ज्यादा कुछ नहीं करने की जरूरत होती है. It works all the way fine by electronic data processing, so no problem. Next one is the errors of echo sounder. When we say errors, ultimately it is that the recording is wrong. Actual depth is something, echo sounder saying something else. Error. Now it can happen, this error can happen due to many factors. One factor is the equipment itself, कि आपका equipment सही काम नहीं कर रहा. Other problem can be the choice of the device, कि आपने कौन सा ट्रांसड्यूसर चूज किया है, कौन सा रिकॉर्डर चूज किया, उसके चलते. There can be other errors which is not dependent on the equipment, which is not dependent on the malfunctioning or galat functioning of the echo sounder. That is dependent on external factors. So some of this can be categorized as equipment error, some can be categorized as external. You have to identify as we go on, you have to identify which one is which. Having understood the functioning of the echo sounder, how it works, you should now be able to tell me what do we mean by stylus speed error. Yes. What should we mean by stylus speed error? Gentlemen?
So the speed of the stylus is not the half of the speed of the sound wave. It's not. It's different from that.
It is more or less. Very good.
Yes, sir.
Very good. So that is what stylus speed error is, and we have seen in the maintenance that it should be maintained exactly at half the speed. So you may have a control provided for adjusting the speed. You may have instruction in the instruction manual how to bring it to 750 meters per second. Next one is Pythagoras error. This error is happening when we have two transducers fitted for transmission and reception. What will happen now? Suppose we are standing in front of the ship and looking from the forward. So the bow is here. We are standing in front of the bow. Transducer will be fitted, two of them side by side in athwartship alignment. One is for transmission, the other is for reception. The signal is transmitted vertically downward, but it hits the seabed and comes back reflected as an energy echo. What we have here is the total distance is traveled is this. Is that correct or not? From transmitter to the seabed,
Yes, sir.
to the receiver. So this is the total distance, this plus this, divided by 2, the depth will be this, That means this diagonal is the depth that we are reading. From the view itself, we can see that this is not the correct depth. Depth has to be the center one, the perpendicular distance from the keel to the seabed, the red one. Now, if the distance between the two transducer was x, in this triangle, one of the triangles, can we find out the perpendicular, the red one, if we have the depth available, that hypotenuse is available, we have that base which is x by 2, we had this was x by 2, we are already getting this depth, then we have to find out this AB, which is the depth. So using Pythagoras error, we can find out this, or we can find out the error that is going to be there. So depth that the echo sounder is giving me is this, but this is wrong. It should be this. This is what is Pythagoras error. This error is prominent in the shallow waters, but not so prominent in deep water. You can see in the first case that there is a difference between the two, but when we go down, there is very few less difference between the two. So this Pythagoras error is significant at shallow waters. Using the formula h square is equal to p square plus b square, which is the Pythagoras theorem, we can find out the depth, or we can find out the error in the depth. We can just subtract from the hypotenuse square to the base square, we can minus, subtract, and we can get the depth square. Under root कर देंगे तो वो भी निकल जाएगा. Then there is something called instrument drift. This is happening when the exact speed of the stylus is not exactly matching. बहुत मेहनत करने के बाद काफी क्लोज तो लेके आ गए हैं. It is almost close to a 750 meter per second, but there is a very marginal difference. तो आपने जब उसको सेटल किया, फिक्स कर दिया, तो जीरो लाइन पे तो आ गई. But what happens because of heating, because of temperature differences and all that, the behavior of the equipment will change, as the current is also dependent on temperature. So what will happen, अगर सब कुछ ठीक रहता और जहाज जेटी पे खड़ी रहती, तो एक खास डेप्थ पे स्ट्रेट लाइन आना चाहिए था. जहाज खड़ी है, डेप्थ फिक्स्ड है, बार बार इको साउंडर का इको आ रहा है, so it should have been straight line. But you see what, that it is not straight line, it is going like this or going like this. That means the instrument is drifting to one side. Either the speed is increasing slowly or speed is decreasing slowly. आपने यहां तो फिक्स कर दिया था सही, बट छोड़ देने के बाद थोड़ी देर के बाद आप देखते हैं कि ये शिफ्ट हो रहा है. सो बीच बीच में चेक कर लेना चाहिए स्पीड इसका सही है या नहीं, कहीं गड़बड़ तो नहीं होगी, यहाँ पे तो नहीं आएगा. This is called instrument drift. Zero line adjustment error. This also we know that when the ship is transmitting pulses, when the pulse is beginning, the stylus should be at 0 point. So there has to be a perfect synchronization between the location of the stylus and the transmission of the pulse. अगर ये नहीं होगा तो आगे पीछे की रिकॉर्डिंग हो जाएगी. Like we did intentionally in case of phasing, यहाँ पे inadvertently होएगा and that will result in error. अगर स्टाइलस पीछे है तो हमेशा कम डेप्थ दिखाएगा. अगर स्टाइलस आगे हो गया तो ज्यादा डेप्थ दिखाया करेगा. So it should be maintained, zero line should be maintained in such a way that it should be at 0 point when the transmission is just beginning, pulse is just getting started. Again, look at the instruction manual to find out how do we do this. Next one is velocity of propagation in water. This is external to the echo sounder. No problem with the echo sounder as such, but the environment in which it is working. This we know very, very well. What is the meaning of this? We have talked multiple times. We have understood. Then there is thermal and density layers, which is also external to the equipment. This is not the problem of the equipment, but it is external condition. Now, what is that? When we have the ship here and the seabed is here, there can be a layer of water having different kind of density and temperature. It is possible that the transducer is receiving some signals from the hair itself. So this will show false kind of echo. You will get a depth which is this, but actually the depth is this. You might also get a second recording. दो recording हो जाएगी, क्योंकि कुछ penetrate करके भी पार हो जाएगा. Seabed से हो सकता है कुछ वापस भी आ जाए. But you will get double recording. So there can be confusion. यार depth ये है या ये है? So you should be certain of this, that this can happen. This particular thing, double recording, can also happen if there are fish in the water. यहाँ पे there is shoal of the fish. ढेर सारे यहाँ पे fish हैं, घूम रहे हैं. तो आपके रिकॉर्डिंग में ये फिश के बॉडी से टकरा के भी इको वापस आएगी, and you will get the recording on your echo sounder. By the way, echo sounder is not only used for depth finding, but by fishermen it is also used to find out the fish. So they are not interested in the depth, they are more interested in the fish. तो जहां पे दिखा उनको नेट डाल दिया उन्होंने. So on the fishing vessels, this echo sounder is a very important device. Amazingly, not for the depth, but for the fish. Then there is something called multiple echoes and secondary echo. These are the results of wrong range selection. आप लोग सभी लोगों ने रडार पढ़ा हुआ है. Multiple echoes on radar. Can somebody explain to me? Yes, gentlemen. What is multiple echo on radar? Yes, go ahead.
सर, जब भी कोई दूसरा वेसल बहुत हमारे पास से जा रहा होता है तो वो इकोस पर डबल ट्रिपल रिफ्लेक्ट हो जाती है, तो वो उसी सेम टारगेट की बहुत सारी इकोस दिखाना शुरू कर देता है. तो उसको मल्टीपल इकोस कहते हैं.
Very good.
दो पैरेलल बॉडी जब होती है तो होता है.
Good. Only one thing, that it is not, when it is just close, the two ships have to be side by side. If the ship is here, then you don't get multiple echoes. है नजदीक में, लेकिन multiple echoes नहीं मिलेगा. Multiple echo मिलता है when we are two ships on the parallel course side by side. What happens? The radar is transmitting signal, it hits, so on the radar screen you get a very good recording. Then signal is coming here. Now your surface also reflects it back the second time, और second time आ जाता है, तो फिर से recording होती है. फिर से चूंकि नजदीक नजदीक में है, तो वो थर्ड टाइम यहाँ जाकर के थर्ड टाइम वापस आ जाता है, तो फिर से रिकॉर्डिंग होती है. सो आपके पोजीशन से इक्वी डिस्टेंट पे मल्टीपल इकोज आएंगे. अगर 1 माइल दूर है तो आपके पास जो रिकॉर्डिंग आएगी वो 1 माइल, 2 माइल, 3 माइल, 4 माइल, ऐसे मल्टीपल ऑफ द रेंज ऑफ द टारगेट यू विल गेट रिकॉर्डिंग. The same thing happens in case of echo sounder also. But this will happen when you have selected the wrong range. Supposing the depth is 25 meters and you have selected a range which is 100 meters. Remember, for 100 meter, the time between two pulses will be such that this will allow 200 meters of travel by the wave, half for going and half for coming back. दो पल्स के बीच में इतना टाइम. Remember, the maximum depth that is measurable is depending on the time between two pulses. तो चूंकि आपने 100 meters का रेंज रखा हुआ है, so a pulse, let us say P1, should be given time to go all the way 100 meters, strike the seabed, and come back 100 meters, total 200 meters. Then pulse number 2 will start. But here the depth is only 25 meters and you are keeping range 0 to 50 or 0 to 100, basically what we said, or 50 to 100. So the signal is traveling and pulse is returned back. Recording हो गई 25 मीटर पे. But the signal then strikes your hull and goes back again and comes second time. So 50 meters पे फिर रिकॉर्डिंग हुई, लेकिन रिकॉर्डिंग थोड़ा सा वीक होएगा, थोड़ा लाइट होएगा, क्योंकि सिग्नल स्ट्रेंथ थोड़ी सी कमजोर पड़ गई है दो बार जाकर. There can be possibility that there is a third reflection. आपके हल से टकरा के, which is also a very good reflecting surface. स्टील है, स्टील का प्लेट है, so very hard surface, good for reflection. So on the screen of the echo sounder, you are going to see recording at 25, 50, 75 and 100. The first one will be strongest signal, the last one will be light signal. Now you will be confused कि depth मैं किसको देखूं, 25 है, 50 है, 75 है, 100 है. What you should do? Change the range scale such that the range that you are reading is lying within the selected range, not outside. Range selector should be selected properly for the depth that you are reading. 25 मीटर का है तो उसी आसपास के रेंज को सेलेक्ट करना चाहिए. Second one is secondary echo interference. This will happen when the again wrong range is selected but in the reverse way. What we had? We said that the depth was 25 and we were selecting 100 meters. Change the case that the depth is actually 100 meters and the range that you have selected is 25 meters. जब ये पल्स चलेगी और 50 मीटर जाएगी, पल्स यहाँ पे पल्स नंबर 1 पहुंच गया, अभी पल्स नंबर 2 शुरू हो जाएगा क्योंकि आपने रेंज सेलेक्ट किया हुआ 25 मीटर का. So time between two pulses will be enough just for 25 meter reading. So pulse 1 is at this place. तब तक pulse 2 starts from here. अब pulse 2 जा रहा है, 1 उतने में टकरा के वापस आएगा. जब यहाँ पे रिसीव हो रहा होगा तो हो सकता है थर्ड पल्स यहाँ शुरू हो जाए, पल्स नंबर 2 यहाँ पे हो और 1 echo is being received. The receiver is receiving the echo from the first pulse when the pulse number 3 is being transmitted. और स्टाइलस तो अपने स्टाइल से चल रहा होगा फॉर रीडिंग 25 मीटर. तो वो जहां पे भी होगा, the recorder stylus in this condition, wherever it is, it will record the depth. ये हो सकता है 15 मीटर पे भी आ जाए, 10 मीटर पे भी आ जाए, 5 मीटर पे भी आ जाए. The recording will be shown at the wrong place. Recording will be shown at the wrong place. Why? Because we are receiving the pulse of the echo of the first pulse in the second pulse transmission time or third pulse transmission time, and that is why it is called secondary echo. Understood the two errors?
Yes.
Multiple echoes में range selected is more than the depth. Depth is less, range more. Secondary echo में उल्टा, depth more, range less. रोड पे है कोई? Okay, there are some dynamic errors, rolling and pitching due to heaving, due to draft, settlement, and trim. These keep on changing from time to time. कुछ तो सही रहता है. अरे मेरी ही आवाज से एरर ही आ रही है, प्रॉब्लम आ रही है. हेलो, प्लीज म्यूट योर माइक्रोफोन्स. So, and all these are changing the situation of the transmission and reception of the pulse. So it will result in draft error in the draft. So any questions on the errors of echo sounder? I suppose no. तो क्रॉस नॉइज एरेशन वगैरह तो हमने पढ़ा था.
Yes.
We also talked about this. What are the corrections to be applied on the echo sounder reading before we compare it with the charted depth? So first one is this: sound wave correction, draft correction, tidal corrections. Additionally, the height of the swell, average swell, wave swell, etc. That is dynamic error only, but that may also have to be taken into account when we are comparing. अगर पानी ऊपर नीचे हो रहा है तो एवरेज करना होगा थोड़ा सा, कभी कम दिखाएगा कभी ज्यादा. That has to be corrected. So with this we are done. Any questions?
No, sir.
take a look at this and verify that you are happy with these questions, you are comfortable. या तो अभी आंसर कर सकते हैं या यू आर नाउ फेमिलियर, थोड़ा पढ़ेंगे तो इसको हम कर लेंगे, यू आर कॉन्फिडेंट. Yes, all good.
Yes, sir.
All right. So then we change over.
So this equipment controls where we just have to write the name or we have to explain
Explain.
every control.
Explain in 1 or 2 lines. एक 2 लाइन का तो explanation है. Remember, BEQ or NAVEX is a theory paper. So theory has to be given to the examiner. जो पेपर चेक कर रहे हैं उनको थ्योरी बतानी है कि हाँ मुझको समझ में आता है. So in general, simple idea should be to explain whatever you're writing in theory. And this paper is little bit lengthy by nature itself. जैसे कुछ पेपर्स होते हैं ऑब्जेक्टिव टाइप है तो आपने टिक कर दिया, हो गया आंसर. तो नेचर है उसका कि टिक 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 करना है. बट यहाँ पे थ्योरी है, इट इज द नेचर ऑफ दिस पेपर दैट इट इज लॉन्गिश, लिखना पड़ता है. सो नो कंप्लेंट्स, कंप्लेंट से कुछ नहीं होगा कि बहुत लंबा पेपर था. इट इज लंबा पेपर ओनली ऑल द टाइम. ऑलराइट, सो एक क्वेश्चन पूछना चाहता था, इस बैच में जायरो कंपास आप लोगों ने किया है? मेरे ख्याल से नहीं.
सर अप्रैल का नहीं हुआ है सर.
अप्रैल का तो ऑफ कोर्स नहीं हुआ है. मार्च का, फरवरी हैज गॉन इनटू एग्जाम. सो मार्च बैच, आई थिंक मार्च बैच को हमने जीपीएस इको साउंडर वगैरह करवाया था. नहीं, मार्च बैच को हमने क्या करवाया?
सर जायरो हो गया मार्च बैच का.